We're going to do nomenclature today, which means naming. So this is Chemistry 1, Chapter 5. We're going to take a look at binary compounds. Binary means two. We're going to abbreviate compounds as Cmpds. So compounds with only two different elements is what a binary compound is. We're going to find compounds that are made up of a metal and a nonmetal, or two nonmetals. So the key to this is you have to know what elements are what. So you have to identify the metals as metals and the nonmetals as nonmetals. So here's a picture of the periodic table showing all the metals in red, the metalloids in yellow, and the nonmetals in blue. And remember, hydrogen's over here in the blue group. So when you look at a binary compound, the first thing you ask yourself is it binary? Are there only two elements? If the answer is yes, then I have to find out if I am dealing with a metal and a nonmetal or two nonmetals. Binary ionic compounds are metals and nonmetals. The cation loses electrons and the anion gains the electrons. So remember, the cation becomes positive because it loses electrons. The anion gains electrons. That makes a binary ionic compound. The rule is you always write your cation first and your anion second. And to name these compounds, we just need to name the ions. There are two different types of binary ionic compounds. Type 1 is going to be a metal or a true metal and a nonmetal. These metals only form one charge, one cation. Type 2 binaries are going to be a transition metal and a nonmetal. Transition metals are a little strange. They can form more than one cation. So let's take a look at this periodic table to identify where those are. So a true metal is considered anything in group 1 except hydrogen and group 2. We also consider aluminum a true metal. It's special over here. Anything else in the trough, if you're dealing with a metal that's in this trough, it is a transition metal, and that's not what we're going to name today. We're just going to focus on naming the type 1, which is going to be a metal out of these two rows, or aluminum, and a nonmetal. So we're going to write the cation first. Name it just like the element is on the periodic table. We're going to write the anion second, and it's going to get named like that element, only it's going to end in ide, I-D-E. Okay, so yesterday, the example we looked at was sodium chloride. Is it binary? The answer is yes. Is it a metal and a nonmetal, or a transition metal and a nonmetal? Let's look at the periodic table and find sodium and chlorine. So sodium is right here, and it's in group 1, so it's considered a true metal. So we have a true metal and we have a nonmetal, so it is a type 1 binary ionic compound. Okay, so now that we looked at the periodic table again, let's go back to our questions. Is it binary? The answer is yes. How do we know that? Because it's one element and another element, so there's two. Is it a metal and a nonmetal, or a transition metal and a nonmetal? We know now that it's a metal and a nonmetal after looking at the periodic table. Next question is, how do we write it? So how do we name sodium and how do we name chlorine? So sodium is just going to be named sodium. You can read it. It looks like a kindergartner wrote it. Chlorine is going to be changed because INE is going to change to IDE. Awesome. So we're going to write it as sodium, change the ending to ide. So the proper name for it is going to be sodium chloride. This is a table out of your textbook. These are common cations for the true metals. We just name them like they are on the periodic table. The anions, however, get their endings changed to ide, and sometimes it's a little confusing when we start to rename the anions. So this shows you what it would look like for each one of them to be changed to the ending IDE. That way you don't have to wonder. Okay, we're going to look at these. Binary type 1 ionic compounds. It already tells you these are binary type 1s. So we look at it, CaCl2. Are there just two? Yes, they are. Are we dealing with type 1? Well, they told us we were. How do I know that I'm dealing with a type 1 with CaCl2? Okay, so what we were dealing with on that other page was CaCl2. So let's find those on the periodic table. So we go over here and we say there's calcium. And over here is chlorine. So I'm dealing with type 1, and I'm just checking that to make sure. Calcium is one of the true metals, and this is a nonmetal. So we're going to deal with naming it like we would according to the rules that we have so far. All right, so we're going to name this calcium. This is not getting any better. Wow. And then chlorine becomes chloride. IDE. Okay, let's look at the next one. SNO. That's not snow, although we wish we had some right now. Okay, now for your viewing pleasure, I took more time to write this compound down. So it's SNO. And we need to find these on the periodic table and to make sure that they're a type 1. So let's find SN. SN is 10. So we're looking up here, and if you notice, it's not in the first two columns, and it's not aluminum. So I look over here, and it's actually considered, because it's under the stair step, a transition metal. So we have SN, and we have oxygen. So is this a type 1 binary? It's not. I haven't taught you how to name those yet, so this isn't one that you can name right now. Okay, just to reiterate, we can't name SNO as a type 1 binary because 10 is a transition metal, and I haven't, that doesn't even look like transition, TM, transition metal. We don't know how to name those yet. We'll deal with that tomorrow. Let's look at CSBR. Is it binary? Yes, it is. Do we have a true metal and a non-metal? Well, let's stop and see if we do. So let's look at our last example, CSBR. So we find where CS is. That's over here in the alkali metals. It is a true metal, so we are dealing with a type 1 binary. Bromine is over here, making it a nonmetal, so it's a type 1. Now we're going to go back and name it properly. Okay, so we decided that CS was a true metal, Br is a nonmetal, so we're going to write it as, so the proper name to name this one, way to name this one is cesium bromide, and the only way to get better at these is to practice.